Okay, now that we have all eaten, replenished our energies, let's talk about data pipelines with Riccardo Magliocchetti, presenting a simple serverless data pipeline.
Thank you. Can you hear me on the back? Okay, thank you. So hi, everyone. My name is Riccardo Magliocchetti. And today I'd like to talk about how to build a simple serverless data pipeline. First of all, I'm not a data engineer. By trade, I'm a backend developer. And so I'd like to build something simple, better if managed by someone else. And by someone else, I mean other companies and not colleagues. So the agenda for today, we see an overview of a simple serverless data pipeline architecture. Then we'll see the data lake we used, which is comprised of AWS tools like S3, Glue, and Athena. We'll take a look at Apache Superset, which is an exploration and visualization platform. Then we'll talk a bit about data formats, and at the end we'll discuss a bit about vendor locking. So the architecture. On the left, we have our application. In our case, it was a Python application, of course, and it was a Django monolith. The Django monolith pushes data to the data lake via S3. Pushing that out is very simplified things. And in this case, particularly, the Django application was already pushing data to S3. So it was already configured to do so. Then, once the data in S3, it is managed by Glue, and is queried by Athena. At the end of the pipeline, on the exploration block, you see Superset, which queries Athena and displays the visualizations. So a bit of the context of this project where we developed this architecture. So the team was small, and there weren't any data engineer on the team. And users were business people and not data scientists. So we can just say, just load it into something on the web and be done. Fortunately, we didn't have any real-time requirements. The data is produced daily. And so this simplifies things a lot. And on top of this, we have just a small quantity of data. We're talking about megabytes of compressed data pushed through the year. So a small application. This is not a job done by myself. So credits to other people in the team, which were Nicola Martino for his AWS knowledge, and Bartolo Vanese, who helped me define the data to export and set up Apache Superset. So let's talk a bit about the data lake. Data lake is a fancy word for just the place where you store and process your data, if any of you is not a data engineer. So our data lake, again, let me explain it a bit. We have S3 to store our data. We have Glue that maps data to something that looks like a database table. And then we have Athena, which is a query engine service, which is able to let us query the data stored mapped in Glue in SQL. So S3, if you don't know what it is cloud object storage, which in simplifying, it's like a persistent cache that looks like file system. It's very cheap to run, but as any other service in AWS, mind the data transfers from and to the internet. It's like a standard, the de facto standard. So every other cloud offering will have a comparable, if not even compatible service. Then on our pipeline, we have this service called Glue, which is a serverless data integration service. It's serverless, so it's pay-per-use. So if you don't have much data, it's very cheap, even if free, maybe. You can do there some transformation. So if you require any cleansing or processing or whatever of your data, you can integrate with an interface which is based on the Apache PySpark libraries. But you can also do something yourself. So maybe you can upload your data on S3, listen for event notification, process your data on maybe on a serverless platform, on a Lambda. Lambda is the AWS serverless computer service. And once you process your data in these Lambdas, you can upload them on another S3 bucket. S3 buckets are like S3 directories, if you don't know. So we are just using the data catalog functionality of Glue, which is, again, the ability to map some files on S3, on a bucket on S3, to something that looks like a database table. So on the end of our data lake, we have AWS Athena, which is a serverless query service. Its only role is to being able to query the data mapping Glue in SQL. It's pay-per-use, and you spend around $5 for terabyte query from Glue. Okay, now we've seen the data lake. We take a look a bit on end of our pipeline, which is the exploration and visualization platform. We choose Apache Superset, which again is a data exploration and visualization platform. It's written in Python using the Flask framework for handling the data. It uses SQL Alchemy, and so it loads data into pandas data frames, and then it renders the charts using JavaScript. It supports plenty of database. At the time of writing this presentation, there were about 40 databases supported. And in practice, if you have any SQL Alchemy dialect available for a database, you're fine to use it in Superset. There's also a SQL editor available in Superset, so you can do your own exploration using SQL. So you can query your data and see what happens. Use an hosted version from Preset.io, which is the company that employs most of the Superset developers, and it stewards the project on Apache. So some concepts on Superset. You have databases and datasets. Databases are just the database you are connecting to. And datasets are the table you want to explore, and expose as a dataset. You have charts. Yeah. Charts are just a visualization of database tables. So we have an example. We have the data queried on bottom. You have the charts on top. On the left, you have the metrics and columns from the table, and the filters and the kind of visualization, the configuration in the second column. Once you have charts, you assemble them in dashboards, which is just a collection of charts. On the filter, on the left, sorry, you can see the filter. So you can filter the data that powers all the charts you have on the dashboard. And as I said before, we have a SQL editor. So if you have, before you have an idea of what chart to build, you can query, have a peek of the data you have in the database. So on the left, again, we have the columns of our table. On top, we have the query, and on the bottom, we have the results and the previous queries, in this case. So let's speak about data formats. We started simple with CSV files, which are being text-based, are the best for debugging because you can use your favorite CLI tools like grep, sort, whatever. And also for debugging, you can load them into spreadsheet, and it's very helpful when you have data issues, data export issues. Problem with text files are that they're not data friendly because they are big, they're not compressed, and they're slower to query. So we optimize for size and move to ORC files, which is a binary, columnar, and compressed format. So we optimize a lot the time spent on reading the files and the space storage they took. Problem with ORC files is that the tooling is mostly in Java. And so we being Python developers, we didn't like that much. And so we optimize for developer experience instead with Parquet files. Parquet files are a bit less space efficient. They're like 15% bigger than ORC files, but they have a huge ecosystem. They're used by Apache Arrow, which is an in-memory format, which has a huge ecosystem now in the data world. And he used Parquet by a lot of interesting projects, like, for example, DuckDB, which we've seen in the keynote before, which is an in-memory analytical database. I think like a SQLite, but for analytical workloads. Now, discuss a bit about vendor lock-in. This solution is based on AWS because this is what the company was already using. And of course, every cloud provider have their own opinion of how you do build a data warehouse or data lake. For example, if you are a Google Cloud Platform customer, you probably be using a BigQuery, which is like everything on Google Cloud is based on BigQuery. Still, all of this can be replicated using only open source software. You can use Min.io as a cloud storage, as our object storage instead of S3. You can use Apache Hive or whatever other Apache project that does the same thing is available to ingest data and query it by Apache Superset. And of course, you can host yourself Apache Superset, which is open source already. So to conclude, you can build simple data pipelines cheaply without much operation overhead. This is very interesting for small teams, especially the one without a lot of data knowledge or data specific roles. In my opinion, serverless makes a lot of sense for small scale because you don't have the overhead of running the infrastructure, and if not much data, it's very cheap. So I'll leave you a bit of references. First one is the AWS idea of the data architecture, which is more or less what we used, a simplified version. An example of how to connect Apache Superset to AWS Athena, and the Apache Superset documentation. This is all. Thank you very much.